Hey everyone, I hope you're doing well today. In this video, let's go over all the questions in Unit 7 Homework 2 so you get a better understanding of how to solve each of these problems. Let's start with part 1. So we have to find the 5 essential points and the IQR. So the 5 essential points are going to be the minimum, Q1 or the lower quartile, Q2 or the median, Q3 or the upper quartile, and the maximum. So those are the 5 essential points or 5 critical points, whatever you want to call them. And then afterwards, we will also find the IQR, which is the range of the middle 50% of the data. Okay, so let's get started. First, for number 1, we have in a bowling tournament, Eli got the following scores in each of his, rounds of bowling. And so let's see. The first thing we're going to do is we're going to just write these numbers in order from least to greatest. So I'm going to look for the smallest number here. I think it's going to be 167. Let's see what's after 167. I'm going to cross them off as I go. I think 178. 178. What's after 178? I think 193. 193. 196. Oops. 196. 199. I think there's two 199s. 203. 209, 217, oops, 220, and then 221. So I think that's all of them. Let's see, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers to begin with, and I have 11 numbers now. Okay, great. So let's see, I'm going to copy some stuff down here. So the minimum, I'll call this Q1 for the lower quartile. I'm going to call this Q2. This is also the median though. Then we have Q3, which is the upper quartile. And then we have the max, which is going to be the highest value. And then I'll have the IQR down here. Okay, so let me go ahead and just kind of copy this so that we have it for later as well. That way I don't have to keep rewriting it. Okay, so going up with the minimum, let's go with the minimum first. So right here we have 167, that's going to be the lowest score, and then 221, that's going to be the maximum score. Not too bad. Then we go ahead, we're going to have to do the median now, or Q2. So if we're going to do that, I think the best thing to do is, well, there's 11 values, so if you find the middle, that means 5 of them should be on the left and 5 will be on the right, and then we have a median. So let's see here, 1, 2, 3, 4, 5. Okay, so this will be the lower half. Okay, and the upper half would be from here, these 4, and then finishing off right over here. So that's the upper half. So that leaves the median here of 199. So that's going to be Q2. 199. So half of the scores were above 199 and half the scores were below. It's the 50th percentile. Okay, now going ahead for Q1, you just have to look at the lower quartile. So for Q1 here, we just have to find the middle of this, and that's going to be 193. That's the bottom 25% of the data. And then if we look at the top half, 1 on the bottom, 1 on the top, 1 on the bottom, 1 on top, maybe a little confusing because it's not on the same line, but I think 217 would be the third quartile. So 25% of scores were above this, but 75% of scores were below it. Okay. And the final thing we're going to do here is find the IQR. So the IQR, if you forget, is going to be Q3 minus Q1, so it's going to be 217 minus 193. I believe that's going to equal 24. So that's the range of the middle 50% of the scores. Okay, that's all you had to do for number 1. Number 1 is complete. All right, number 2, following is the number of miles that Mila ran each week for the past 10 weeks. Okay, so let's just start off by writing in order from least to greatest. So I think we see a 4 here. And she did, was there another 4? No. I think 6 was the next one. And I see 2 8s. Hopefully I'm getting all these correct. 8 and 8. 9 and 11. I see a 9 and 11. I'm drawing 2 at a time here. I see a 12. And then a 14, 14, 16. 14, 14, 16. 14, 14, 16. Okay, cool. So I got a little shortcut. Just copy and paste that. Okay, so let's find the minimum first. So the minimum is going to be 4. It's pretty easy. The maximum is 16. That's the most amount of miles she ran in a week. And finding Q2. Well, there's 10 numbers here, so that's an even number of numbers. So half of that's 5. So we need to have 5 numbers on the lower half. 1, 2, 3, 4, 5. And for the upper half, we also have 5 numbers. So 1, 2, 3, 4, 5. Okay, so whenever this is the case and you have to find the median and there's an even number of numbers, remember you have to go in between this 9 and 11, or the middle between them, the average, and that's going to be 10. So that's going to be the median, the 50th percentile. Okay. On the bottom half, to find the lower quartile, or Q1, we have to go in between these numbers, and it looks like we have 8. Okay, so 8 is going to be quartile 1, or the lower quartile, and then for the upper quartile, to show the top 25%, we're going to get 14. Okay. Finally, what we're going to do is we're going to take Q3 and subtract Q1. So that's just going to be 14 minus 8. That'll give us the IQR. So half of the data is only 6 apart from each other. So a smaller IQR than in number 1, which means the data is closer together. Or the 50% in the middle is closer together. Okay, so that's 1 and 2. Let's keep on moving on here. Here is number 3. We have 20 students who ran the 400-meter race, and their times were recorded in seconds. Okay, so we're going to have to write these numbers in from least to greatest. So who is the fastest here? So I think I see 59. I see a 58. I think that's the lowest. So let's just go ahead and write this down. So 58, I think, was the fastest. And that would be very fast for middle school. 58, 59 is also quite fast. I see a 62, 262. Is anything smaller? No. I see 62, 62. Just make sure you're careful. Oh, no, sorry. There is a 61. So let me just move that over. 61. Did I miss anything else before I keep going? I don't think so. Yep, just be careful. It's easy to miss some of them. 65. I see 2 65s, 3 65s. Let's check this out. 65, that's 1. 65, that's 2. And 65, that's 3 of them. Let's go for 66 and a 67. 66 and 67. We have a 68 and a 69. I see 71. 74, 74. 76, 77. 83, 87, 92. Let's see. 83, 87, 92. 20 students. Let's count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I think I have them all. Hopefully I didn't miss any or write any down incorrectly. But either way, hopefully we have the right process down here. So 58 is the fastest, okay? And 92 was the, slowest. I'm going to put that over here for the max. And there are 20 students, so think about that. What's half of that? That's 10. So I need 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This right here is going to be the bottom half, or the lower half. So these were the fastest half of the people. Remember, the lower time's better here. And then for the upper half, or the slower 50%, those are these times right over here. Okay. If you want to find the median, because there's an even number of numbers, we'll have to go in between. So 67.5, that's going to be right in the middle, 67.5 seconds. So to be in the top 50%, you have to be faster than that. To be in the lower 50% or slower, you'd have to be slower than that number. Okay. Now for the lower quartile, that is, let's see, 1 and 1, 2 and 2, 3 and 3, 4 and 4. And we have 2 middle numbers here. So what's between the 62 and 65? Well, they're 3 apart, so half of 3 is 1.5, so add 1.5. This should be 63.5. Okay, so remember, you have to go in between the 62 and 65 here. That's going to be 63.5 seconds. So if you were faster than 63.5 seconds, you're in the top 25% of runners here, right? 75% of the students were slower than you. Now for Q3, let's go one on the like 2 off the bottom maybe, and then 2 off the top, 2 off the bottom, 2 off the top. And again, we have 2 middle numbers here. So we have to go between 74 and 76. I think that's going to be 75. Okay, so if you're in slower than 75 seconds, then you're in the slowest 25%. And if you're faster than 75 seconds or a shorter time, then you're in the top 75% of these runners. Okay. Next for the IQR, very straightforward. We're just going to take the 75 and subtract. We're going to find the range of the middle 50%. So 75 minus the 63.5, that should be equal to 11.5. So the middle 50% of the runners were within 11.5 seconds from each other. Okay, that's number 3. Taking a look at number 4, let's scroll down here. Okay, 17 students took a math quiz and received the following scores. So let's just go ahead and write these down in order from least to greatest, just like before. Oh man, I missed one already. Sorry, let's go with 56, then 58. Anyone in the 50s? No. In the 60s? Someone got a 68. No more 60s. What about 70s? Maybe 76. And 78. Anybody else in the 70s? I don't think so. Let's go to the 80s then. Let's go 84. 85. Let's see, 2 86s. 87, 88, 89, 91, oh, another 91, 94, 95, and 100. I get all 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, a little paranoid, but just want to make sure I have them all. All right, so let's go ahead and find out all of our information. So 56, that's going to be the minimum right over here. And the maximum should be 100. So that's right over here. 17 people. So half of 17 should be, well, what's half of 16? That's 8. So 8 numbers on the left and 8 numbers on the right. So there'll be the top 8, or sorry, this is the bottom 8. 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 worst scores, or the 8 lower scores rather. And we have the 8 best scores, right? So if we cut it in half, we have the 8 best, 8 worst, or 8 highest, 8 lowest, whatever you want to think about it as. And what would be between 86 and 86? Well, that's convenient. We don't have to do a lot of work. Half the kids did better than 86, half did worse. Okay. Now to figure out who did in the bottom 25%, let's go ahead and cut these in half to find the middle. 3 on each side. What's between 76 and 78? That's 77, right? So if you did worse than 77, you're in the bottom 25% of the class. But if you did better than that, you're in the top 75% of the class. You have to go in between those. For the top, let's go 1, 2 off the bottom, 2 off the top, 1 off the bottom, 1 off the top. Do that right? Oh no, wait, I think, yeah, I messed up here. Sorry about that. Let me go back. I didn't split this in half correctly. There's 17 numbers, so there should be a middle one, right? So 1, 2, 3, 4, 5, 6, 7, 8. Let's count right here. I went too quickly. 1, 2, 3, 4, 5, 6. That's 7 numbers, right? And then this is the 8th number. Yep, if there's an odd number of numbers, there's going to be an individual median that we don't have to find the middle of. So I guess it still ends up being 86, but I just want to make sure we did that correct because that could change our lower or upper quartile. So that's 86, okay? And let's check out the lower quartile. So there should be 8 numbers here. There we go. Yep, there should be 2 middle numbers. So between 76 and 78, this is still 77. It didn't really affect this one, but it does affect the upper quartile. So let's go 1 off the bottom, 1 off the top. Another 2 off the bottom, maybe 2 off the top. Maybe it wouldn't have, I guess, but it could in another case. It just happens that we have 2 91s here. So Okay. Finally, for the IQR, let's see how far apart or the range of the middle 50% was. So that's going to be 91 minus 77. So 91 minus 77, that's going to give us a range of 14. So half the students that were close to the median, half the middle students, right? Those students were 14 points away from each other. That's how far they were spread out. Okay, that's number 4. Let's check out number 5 here. Explain what Q1, Q2, Q3 represent, and which one is a measure of center. Okay, so quartile 1, I'm just going to abbreviate as Q1. This says 25% of the data is lower than this value. You can also say that 75% of the data is higher than this value. Okay, for Q2, let's save a little bit of time here. It's a lot of writing. So, whoops. For Q2, what's a little bit different is this is also the median, right? So this is saying that 50% of the data is lower and then 50% of the data is higher. Okay, and finally, for the last part, we can also think, what does Q3 represent? Q3, the third quartile. What we're saying about that one is it's just kind of flipped, but 75% of the data is lower than this value, and then 25% of the data is higher than this value. So let's just go ahead and highlight that. So this is 25% is lower, and then 75% of the data is higher. And this is of Q1. For Q2, 50% of the data is lower, but then 50% of the data is higher. And finally, for Q3, 75% of the data is lower, but then 25% of the data is higher. In terms of which one is the measure of center, the measure of center is going to be this one, right? Because half of the data is above it and half of it is below. So this is going to be the measure of center. Okay, hopefully that makes sense what these quartiles represent. And last question for part 1 of your homework, going over these practice problems. What does it signify when the data has a large IQR as opposed to a small IQR? Okay, well, if we look at a large IQR, that means the range of the middle 50% is really spread out. Okay, that's if you have a large IQR. Now, what if you had a small IQR? This just means the range, well, let me just kind of go ahead with this. This is the range of the middle 50%. If it's really small, whoops, I guess I wanted to use this color just to keep it consistent. The range is really close together, or you can say like concentrated or something like that. So just something to kind of understand is, you know, you can have a large IQR, a small IQR. It just lets us know it's a measure of variability. Lets us know if the data is really close to the middle or if they're really spread out from the middle. Just kind of lets us know how everything is spread out. So there you have number 6. Okay. Okay, let's move on to part 2. Part 2, we have to create some box plots and then answer, I guess, one question or so about each of these questions. So first one is 20 students. Okay, so this is the 400-meter race that we kind of talked about earlier, and it's the same exact data, or it should be. And so I'm going to just come up here. Where is that race? Here it is. And to make our box plot, we really just need the 5 important points here. So let's copy that for question 7. Yeah, question 7. And take that right over here. And we need to create a box plot. So let me go ahead and see if I can do that pretty accurately. So create a number line. And we could give it a title, but I'm going to kind of skip that for right now. And let's see, the lowest score was 58, so we should have something as low as 50, or the time, and make sure we cover all of it. So 50, let's call this 55, I'll call this 60, I'll call this 65 and 70, 75, 80, 85, 90, 95, and 100. I have a little bit of space, so why not? I'll go to 110, even though the data doesn't really need to go that high. Okay, so I guess I could line this up a little better. All right, that's fine. So we have a number line here, and that's going to help us with our box plot. So going ahead with our minimum was 58 seconds, so that was pretty fast. 58, I don't know, it looks something like right over here. And our slowest time, this is backwards because higher times are slower, right? This is going to be the maximum. And we have to go ahead and do the median. So the median, I'll do Q1 and Q3 next, maybe. Q1 is going to be 63.5. That should be closer to 65, but closer to 60, not 70. And close to 75 for Q3. Okay, I accidentally deleted a line here. 70. No, I didn't. That's fine. I just didn't space it out very well. 75 is right here. So there is our box. That lets us know where the middle 50% of the data is. And where is the median? 67.5. I think that's right-ish, right there. Okay. And going ahead and just connecting the top 25%, or the slowest 25% over there. The fastest 25% was actually kind of concentrated. And this would be our box plot, okay? And it says the question is asking us to be in the top 25%. That would be here. Let's write that as top 25%. Because remember, smaller numbers here is better, not higher numbers. If there was a test score, we want higher numbers, but for times, we definitely want something lower. So top 25%, what do you have to be? You have to be under this number here. So what time is needed to run to be in the top 25%? You're going to say you have to be faster than 63.5 seconds. Okay, that will be number 7. Number 8, this is talking about the students who took the math quiz. So let's see. The math quiz here, and those were the scores. Okay, so we actually did that earlier, so let's just go find our 5 important numbers with the quiz score. Oh, here it is, the science quiz. We just need these 5 important numbers for now. There we go. And we need some sort of number line. Trying to make it somewhat neat. So we have to go, 56 up to past 100. So I don't know. We'll go from the bottom here. So we'll go as low as 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and 105. I have some space for that. So again, try to make it as accurate as you can. I think that's good enough. You should give it a title, but again, we're talking about math quizzes or whatever quizzes, science quizzes, whatever you want to call it. And so the minimum is going to be 56. So it's a little higher than a 55. So maybe right here. The best score in this class was 100. So it's right about here. And for the lower quartile, 77 was the lower quartile. So that's close to 75-ish. Okay. And 91, that looks like that would be about here. So this is where the middle 50% of the class scored, between 91 and 77. That represents the IQR, the range of that. And 86 will be right about here. Okay. Here's the best 25% of the scorers. Here's the bottom 25% or the lowest scores. Okay. Now, what does the question ask us? It asks us to state the minimum. State what the minimum and maximum scores are to be in the middle 50% of the scores. Well, again, the minimum and maximum to be in the middle 50%. So let's kind of just mark that up. Right here, oops, I can do that better a little bit. Here is the middle 50% of the data. So when it asks you the minimum and maximum scores to be in the middle 50%, that's really just saying what is Q1 and Q3, right? So that tells us where the cutoff is to be in the middle 50%. If you're above the 91, you're not in the middle 50%, you're in the top 25%. And if you're below 77, you're in the bottom 25% of the class, okay? So that's what that's saying. So to be in this, you have to be, for the minimum to be in that cutoff, in this middle 50%, you have to be 77. And for the maximum to be in this middle 50%, it's a 91. Again, I'm not saying this is the min and max of all of the data. I'm saying this is the cutoff to be in the middle 50%. So a different min than the one we were talking about earlier, min and max. The 56 and 100 are the range, help you find the range of all the data, of 100% of data, not the middle 50%. Okay, there's 8. Let's go on to 9. In a bowling tournament. We did this one earlier, right? With Eli. So let's look for the data for that, what we found out. Okay, that was the first question. So here's the bowling tournament right over here. Let's take these. Okay, and we have some scores here. And let's see if I can make a quick number line. Let's see, the minimum was 167, so maybe I'll go with like 160. And 165, we'll go with 170, 175, let's go with 180, 85, 190, 200, 210. I think I wanted to, this might happen to you too sometimes, right? Just not spacing it out well. Let's try this again. So 160, a little closer. Okay, so just had to make sure I could fit in the 2 up to past 220 so I could fit the 221. So always write enough numbers to fit all of your data in. Sometimes you might need a couple tries if you don't plan it out accurately to begin with. So 167, that looks like it's down here roughly. Okay, and then 221, I think that's up here. Now let's go for Q1 and Q3. So 193. I think that's right around here. And 217. I think that's right above here, right past 215. Okay, that's the middle 50% of the scores. And to be in the top 25%, there's a small range there. They're pretty close together. And there's the bottom 25%. It's usually more spread out. It's usually what ends up happening. 199. That is right around here, right below 200. Okay, there's our box plot. Now, what's the question they ask us? State what score Eli needs to be in the top 50%. So that's going to be top 50% of scores. Again, higher scores are better here. So this right here lets us know this is where Q2 or the median is. This is the top 50% of the data. So to be in the top 50%, he needs to be above what? He needs to be above this 199. If he scores above 199 and he's better than half of the, well, 199 represents like what you'd have to be above to be in the best 50%. So better than half of his other scores. There's number 9. Let's check out number 10. This is the one for Mila. Okay, let's go check that out. I think that was on the first page. Yep, there we go. Oops, I don't want to do that. Right over here. Okay, so here we have these scores, and let's make a number line. I don't think that's straight. It's not a big deal. it's just bothering me a little bit. So let's see, the minimum is 4, so maybe I'll start with 0, but I only have to go to 20, right? So 0, maybe I'll do 2, 4, 6, 8, 10, and then 12, 14, 16, 18, 20. And I can do more if I want, but so I'm not going to write in every single number. Hopefully that makes sense if you see the little tick marks, you know, how much each space represents. So 4, 2, 4, that's going to be right here. And the maximum is 16. So 10, 12, 14, 16. 16 should be here for counting by 2s. I don't know why I'm drawing these lines so long now. So 4 should be right around here. Oops, 4 should be right around here. 16 should be right around here. The lower quartile is 8. And the higher quartile, upper quartile is 14. There we go. So she ran half her miles between there. And there's the 50th percentile. So she ran half her miles more than 10, and half of them were less than 10 miles. Okay. Now the question is asking us, what is the minimum number of miles Mila ran that was in the top 25%? So where's the top 25%? That is right here. Top 25%, I guess we're assuming, right, that's the longest. So what number is that going to tell us? Well, Q3, right? Anything above 14 will be like the top 25% of the mileages that she ran. So above 14 miles. Anything above 14 miles would be in her fastest 25% of the miles that she ran each of those days. Okay, there's number 10. Okay, check out number 11. 2 groups of middle schoolers, group A and B, went shopping. The box plots summarize the distribution of the amount of time each group spent shopping. And we have to answer some questions. So part A rather, says which group had a lower quartile 2? Okay, so for the lower quartile 2, we need to look here. Here's quartile 2. That looks like it's about, I don't know, 48 or so, just kind of estimating. And quartile 2 over here, this looks like it's about 40, right? So half the people spent more than that amount of time shopping. So which one had a lower quartile 2? This is going to be group B. And if you were trying to say a reason, you can say that 40 is less than 48, and that would be good enough. The top 25% of longest shoppers, so this is longer, more minutes, okay, were higher in group A or group B. So this is actually probably like not a fantastic question now that I read it a little bit more and think about it a little bit more. So the longest shoppers, I guess like it depends, like you really don't know, but it looks like group B is slightly higher. So if we take a look here, let me get rid of this and let's take a look at this again. So here's the top 25% and here's the top 25%. We don't really know which one spent longer because they could in group A, most of them could have been at the very top if you're adding up all the minutes. So not a great question, but I guess if we reframe it to like the more concentrated or the, you know, who in general, I guess, shopped longer, I think you'd have to go with group B, right? You can see that the data here is a little bit more concentrated at higher times than lower times. Again, it's not definitive. I think it's actually not a good question, to be honest. Sorry if that kind of confused you a little bit, but we should say it's group B here, even though we don't really know for certain, but I think it's maybe a good conclusion to come to here. Okay, so just looking at which one is more concentrated for longer amounts of time. Okay, moving on to part C, which group had a lower quartile 2 time? Well, this was also not a fantastic question, I think, just because it's redundant as an earlier one. So if you knew this one correctly, this has to do with it. Maybe it's just, you know, another way to think about it, but we're going to just say group B again. Same question. Nice and easy. To be in the lowest 25% of the shortest shoppers, so just trying to clarify that, lowest 25% meaning short shoppers, less time shopping. To be in group A specifically, what time did they shop under? Okay, well, who was the fastest or the shortest shoppers in group A. That's right over here. And if we look, like how long is that roughly here? That looks like it's 30 minutes. I think that says 30 minutes roughly. So let's go under 30 minutes. Okay, there's number 11. Number 12, let's see, 2 different math classes took a test and their scores were summarized using the box plots below. Okay, and let's see here. If you want to take a look at, say, 75% of the students in period 2, okay, just looking at period 2, scored higher than what score? Higher than what score? Okay, just look at period 2, which is right over here, and 75% of them, okay, well, this is 25% of the data were in the bottom. That means this represents the top 75% of the class, so we have to look at Q1. So what is Q1 here? That's going to be 80. So 75% of the class scored above an 80. Okay. Now for part B, it says which class period had a greater IQR. What does this mean? Okay. So IQR, that's going to be from here to here. It's the range of there to there. So what is this? This looks like it's about 90 for Q3 and 75 for Q1. So for the first period, the IQR is going to be 90 minus 75, which is 15. And if we look at second period, looks like this is, I don't know, this is roughly 91, I would say. And this is 80. Okay. Again, it's a rough estimate, but I think it's clear which one's bigger. I think that's the bigger takeaway here. It's definitely not going to be that close. So 11. It's not like we would be off by that much that it would change this. I think it's clear that one box is bigger than the other. So which one has a greater IQR? Well, we can say first period. First period definitely has a greater IQR, and it just means that the middle 50% was more spread out. There was greater variability. Spread ends with a D. Okay, that's really what that means. And for part C, it says, what was the top 25% or the bottom 25% of the students in first period more consistent with their scores? Okay, so let's get rid of all this. Just looking at period 1, which is right over here. Whoops, that's not my highlighter. This is my highlighter. The top 25% or the bottom 25%? Okay, so top 25% was here. Top 25%. And the bottom 25%, I'm going to put bot for bottom. Bottom 25% was right over here. So who is more consistent? Well, we're seeing which one has a greater variability, which one's more spread out, right? So if you see this distance here, this looks like a greater range, and this looks like a shorter range, more concentrated. So more consistent, I would say it's the top 25%. All right, their scores were closer together on average. Top 25% were more consistent. Cool, there's number 12. Okay, that finishes part 1 and part 2 of the problems. Moving on to part 3, let's move away from box plots and start looking at some histograms and frequency tables. Okay, so we have 24 different students took a science quiz. Let's just kind of go through this piece by piece. But we just have to organize and put these into bins or into their tallies. Put the tallies into the bins or where the scores go. So 72, I think that goes here. I think this is the one where it's going to spill over a little bit. 88 is here. 51, 90, 89, 85. Yeah, I think it's this one. 74 is here. 87, 100, 80, 99, 87, 96, 99, 84, another 84, 86, 94, 88, 91, 85, 78, and 90. Okay, so let's go ahead. Our frequency looks like we have 1, 0, 2, 5, 12, and 4. Okay, so filling in a frequency table isn't too bad if you're already given the intervals. Then go over here. Oh, this is the one where I hit a mistake. This is scores, quiz scores. That's what that should say. And I don't know, I won't make this too crazy, but let's go ahead and just make a bar up to 1. Okay. And the next one is a 0. Nobody got between a 55 and 64. Next one is between a 65 and 74, so 2 people got a score here. And how many people got between a 75 and 84? In that interval, there were 5 people, so the frequency was higher here. Okay, this is good. All right, higher scores, more people got these. Between 85 and 94, what was the frequency? The frequency was up to 12, right? 12 students got scores up here. Okay, and then finally between a 95 and 104, there were 4 students who got this score. So let's go ahead and put that. There's a histogram, okay? It's all, you just have to take the frequencies and just make those as bars, make sure the bars are touching, and the intervals or those little mini ranges at the bottom, those bins are not overlapping at all. So let's answer some questions. How many students scored between 55 and an 84? Well, let's see here. 55, you'd have to look over here, and 84, you'd have to look over here. So we're looking for that range. So 0 students scored here, only 1 student here, or no, sorry, 2 students. What am I doing? And 5 students scored here. So if you were going to say how many students, you would just look at those bars and add them up. That's 7, so you can say 7 students scored between a 55 and an 84. Which score, for part B, which score interval had the most frequent amount of students? That one's clearly this interval right here, between 85 and 94. So interval was between 85 and 94. So most students got a score between 85 and 94 compared to the other intervals. Okay, there you have number 13. All done. Let's check out 14. 14, in a recent track and field meet, the following 200-meter race times were recorded in seconds. Okay, so let's go ahead and just start putting these into bins right away. 31.3, that goes here. 30.3 is here. 29.4, 28.6, that's pretty fast. 29.5, it's here. 27.1, 32.5, 30.9, 31.1, 32.8, 31.7, 30, 32.9, 30.6, 29.8, 30.6, I think that's 5, 32.7, 32, 32.8, 32.6, 31.8, 31.2. Okay, so frequency, 1 person got this, 1 person got this, 3 people were between here, 5 people between here, 5 people between here, and 7 people between here. So frequency table is now complete. We now know the frequencies, and we can go ahead and make our histogram now, right? So looks like only 1 person got this time, right? That's very, very fast for middle school. And only 1 person got this time. So again, that's another pretty fast time. 3 people, and hopefully this makes sense. If you're looking at like distributions for like athletes especially, it's usually you're not going to have as many people get the hardest things, the hardest times. Obviously if everybody could do it, it wouldn't be as impressive. So as we get slower, more people are capable of doing that. So you're going to get this left skewed data set. you can see this, that it gets higher as we have more frequency with the intervals with slower times. Not a bad thing, just should make sense when you think about it. Okay, so there we go. It's left skewed. There's our histogram. It's all done. How many students got between a 27, for part C, that is, between this 27 and 30.9 seconds. So 27, that's the fastest, and 30.9, that's right over here. So we want to add the one person here, plus the one person here, plus the 3 people here, plus the 5 people here. So 1 plus 1 is 2, plus 3 is 5. So there were 10 students who ran between those times. Okay. Which score interval, looking at part D, which score interval had the least frequent amount of students? Well, I think we're kind of tied for 2 of them, right? So that's this one and this one. So we can go ahead and say the 2 that were tied were 27 to 27.9 and 28 to 28.9. Okay, so that's D. And for E, it says which interval of seconds is the median located? Okay, so let's go ahead and write these numbers in. We also have 5 people here, and then we also have 7 people here. So if you're just looking at a histogram, the way you can think about this is, let's see how many total people there are. So 1 plus 1 is 2, plus 3 plus 5, that we already know that's 10 from earlier. Plus 5 is 15, plus 7 is 22. So we have 22 people in total. And if you didn't know the data, like if you didn't have a frequency table or the original data set, you can still find out which interval that the median is going to be in without actually seeing the data, right? And the way we do that is we have to find the middle. So if there's 22 total people, that means 11 and 11. If you split the data in half, you have to find the 11th person and the 11th person. So let's go ahead and see if we can kind of understand what we're doing here. So imagine if I took away like 1 from the bottom and 1 from the top, that would now be a 6, right? If I took off 1 from the bottom and 1 from the top, that would now be 5. If I took away 3 from the bottom and 3 from the top, this would now be a 2. I could take away, I guess, 2 from the bottom and take away 2 from the top. That would now be 0, right? Now if I took away 3 from the bottom and 3 from the top, there's 2 left. So where are these last 2? Well, even if you have to go between these last 2, we would be between this interval. The 2 middle numbers would be between here. So again, you don't really need to know what the data is, but you can find out the median is going to be in the interval of 31 to 31.9 seconds. We don't know like what specific time it is, but we do know that the median is located in this frequency, or this interval rather, of the histogram. Okay, cool. I think that is the end of 14. So we did part A, part B, we did part C, part D, and part E. Okay, moving on. Number 15. Let's take a look at this question. It's talking about playing mini golf, and some ages of people were recorded here. So there was a 7-year-old that goes here. There was a 9-year-old here, 18, 45. Where's 24? Here, 12, 14, 75, 12, 17, 14, 21, 6, 15, 16, 19, 10, 32, 56, 47, 9, 14, 15, 4, 27, 22, 17, sorry about that, 13, 11, and 12. Okay, let's see, there are 19 people here, 6 people, 2 people, 2 people, 0, and 1. Hopefully this makes sense. I mean, I would argue that most people playing mini golf are going to be younger. I guess you might have some people going with their grandparents, or grandparents just going on their own, I don't know. And maybe a few parents chaperoning or bringing, I don't know, some kids to mini golf. Someone's got to drive them there, I guess, right? So, yeah, okay. So this kind of makes sense why there would be a lot more younger people typically playing mini golf. For a title here, or that part's done, right? Part A. Let's make our histogram. We want a title, so let's call this mini golf. Mini golf ages. Intervals, this is going to be age ranges. These are the intervals. And this is going to be number of people, or number of golfers, number of people going along the y-axis. This will be our frequency, okay? For the intervals, that's probably the next best thing to kind of go in and write in, is we have 4 to 17, and then we have 18 to 31, we have 32 to 45, 46 to 59, 60 to 73, and 74 to 87. The highest number we have to go up to is 19. So I'm thinking we have, what, 6 boxes going up? We have 1, 2, 3, 4, 5, 6. So 19 divided by 6 is 3. If I go by 3s, we'll end up at 18. That's not enough. So let's go by 4s instead. So I'll go 4, 8, 12, 16, 20, and 24. So it goes higher than we need, but it's better than having more than enough than not enough. So where's 19 going to be? I think that's going to be 3/4 of a box. Again, if every box is worth 4, then 19 would be 3/4 of that box. So here's where most of the golfers, the mini golfers, the ages, this is the most frequent age group. And then there were 6 people in the next one. 6 is between 4 and 8. So I'll go with something like that. 2 is the next one, so that's going to be between 0 and 4. We have another 2. Again, we have less and less people as we get older. No one was between 60 and 73, but we did have one person, so this is 1/4 of a box. Again, every box is worth 4, so try to draw 1/4 of a box down here. Here we have a right skewed data set because more people were younger and less people were older, so when the data is concentrated on the left, it is right skewed. Okay. How many people, well, there's our histogram. How many people were between the ages of 46 and 87? So 46 was here, 87 was here, and it looks like there were 2 people and 1 person here, so 2 plus 1, there were 3 people. Which age group, so that was between this 2, which age group had the most amount of people? Okay, well, we're just going to say that one's obvious to us. That's going to be from 4 to 17 years old. Which age group is the median in? Okay, so let's go ahead and write this down. So we know we have 19 people here and 6 here and 2 here, right? So let's go ahead and take away 1 off the top. That's now 0. 1 off here, that's 18. So cross off 1 on the left, 1 on the right. Cross off 2 here and cross off 2 here. That's 16. Cross off 2 here and 2 here. That's now 14. Cross off 6 here and cross off 6 here, that's going to be 8. So if you cross off all the numbers, the last 8 numbers are still all in this first one. So even if you keep crossing them off, the middle is going to be in that first one. So we know that the median age is still going to be in this 4 to 17, just because so many people were in this age range. Okay, so that is where the median is located. Again, we don't know what it is unless we had the original data. We're assuming if we're not scrolling up and we don't see it, this is all we can really say. So there we have C, D, and E. Okie dokie. 16. The amount of free throws a bunch of students could make in 60 seconds were recorded. So someone made none. That's probably me. 3, 2, Someone got 4, 6, 2, 9, 0, 4, 2, 6, 7, 19, 3, 22. Impressive. 13, 3, 7, 4, 2, 0, 5, 3, 7, 11, 14, 8, and 4. Total frequency, 11 people here, 10 people here, 3 people, 2 people, 1 person, 1 person. All right, histogram is complete. Hopefully I didn't miscount anything. If I did, hopefully you understand where I made the mistake though, and you know like what you're supposed to do. As long as you understand a concept, that's important, but hopefully I did these correct, okay? Histogram, I don't know. Let's call these ballers. I don't know, something, whatever you want to call it. And we'll call these, I guess I can use the same color. Let's say shots made. And then this is the number of students, And let's go ahead and write our intervals in. So between 0 and 3 shots, between 4 and 7 shots, 8 and 11 shots, 12 and 15 shots, 16 and 19 shots, and 20 to 24 shots. And we need to go up to 11. So I think if I go by 2s, I can make it there, right? So 2, 4, 6, 8, 10, and 12. Okay, we need to go up to 11 on the first one. We need to go up to 10 on the next one. And we need to go to 3 on the next, then 2, then 1, and then 1. Just do them all at once here. Go all the way down. There are our bars. Again, I'm not spending too much time making it look super nice, but hopefully this makes it just a little bit nicer or more clear. Sometimes the dotted lines get a little confusing to look at. Okay, but there we have our histogram. Is the data symmetrical? I'll check that off. Is the data symmetrical? I don't think so. Left skewed or right skewed? And what does this mean? Well, again, if our data is mainly on the left, this is right skewed. And what does this mean? It means that most students, or we can say few students made a lot. Or we can say most students made few. Few students made a lot of these free throws. Okay. How many students made between 8 and 19 free throws? Well, let's see, where's 8? 8 starts here, and where's 19 end? This is 16 to 19. So there were 3 people here, 2 people here, and just 1 person here. So if we say 3 plus 2 plus 1, we can say there were 6 students. Okay, and for part E, how many students made between 4 and 15? So let me just erase this so it's not confusing. 4 starts here, and 15 ends here. So this is 10 people, 3 people, and 2 people. So 10 plus 3 plus 2, that's going to be 15 students. All right, and I think that ends number 16. All right, let's take a look just at 17 and see. We just have to answer some questions. Okay, we already have a histogram drawn here. These are nice and colorful. Number 17, we have to then look at part A. Which interval is the least amount of visitors? I think that's just going to be this one right here. So 20 to 23 visits. Okay. which interval had the most amount of visitors? I think that's going to be right over here. So 0 to 4 visits. How many people, that's part B. Part C, how many people went to Chipotle between 5 and 23 times? So 5 is here, and where does 23? 23 is over here. So I think we had 12 people, 16 people, 6 people, and 4 people. So 12 plus 16, that's 28, plus 6 is 34, plus 4 is 38, I think that's right, equals 38 people. Okay, next question, I might want to just get rid of these bars. 15 and 27, I'll keep those numbers because they might help us. So 15 starts here, 27 ends here. Okay, so I just need this 8 over here. 6 plus 4 plus 8, it's going to be 18 people. Can you figure out the mean or the median by looking at this? Can you find the mean or the median when looking at this, and why? The answer is no. All right. Again, like earlier I was kind of mentioning, if you had a data set, you can find out that information. But if you're looking specifically at the exact mean or the exact median, there's really no way of knowing, because if you look here, we know that there are, 18 people that are in this range, but we have no idea like how many visits they actually had. All 18 of these people could have visited 0 times. All 18 of them could have visited 3 times. And it could be a mix of all of the numbers between 0 and 4. And so if we don't know those specific numbers, you can't tell the specific mean or the median. So hopefully that, the explanation kind of makes sense. We can't calculate it if we don't know the specific numbers. These just group the numbers and let us know what, how many are going into each bin, but we don't know specifically what they are. So long story short, we would need to know the exact number of visits of each person, and you can't see those or see that information looking at a histogram. Okay, so again, we know generally what the trend is and what the distribution looks like, but we don't know specific values just looking at it. Okay, and 17's done. I think we did all the parts. 18, use the following histogram to answer these questions. Okay, so for part A, what are we talking about? Jolly Ranchers eaten. We're talking about number of Jolly Ranchers and number of students. Okay, which interval did the most students receive Jolly Ranchers in? So I think the most is going to be this one, 25, and that was 40 to 49. So 40 to 49 Jolly Ranchers. Okay, that's done. How many students received between 20 and 49? So 20 and 49. So there's 20 students got these, 15 students got these, and 25 students got these. So 20, 15, and 25. Let's write that. 20 plus 15 plus 25. And that's 35. I think that's 60, right? 60 students. Okay. How many students received more than 10 Jolly Ranchers? More than 10. That's from here onwards. Okay, so that's 10. We already knew this was 20, 15, and 25. So we actually knew that's already 60. So 60 plus the 10 is 70. We have another 15 over here. So 60, 70, is that 75? No, 85. 85, I think. Yeah, I'll just go write these numbers in though. So that's going to be 10 plus the 20 plus the 15 plus the 25 plus the 15. There's 85 students who got more than that. So for part B, we said between 20 and 49, this was just more than 10, right? So those are not too bad, just a little bit of adding, just making sure you understand how to read the histogram. And can you find the mean, median, or mode when looking at histogram, and why? So we talked a little bit about this in the last one. Can you find any of these specifically? The short answer is no, because we don't know any of the specific values. However, right, big but here, oops, I said big but, however, if you were asked which interval, you can find out which interval. You can't find out what the actual one is, but you can find out which interval. Okay, specific. It's not what it actually is, but we can find out where it is, which interval the median is in. And that's if you cross off left and right. You can find out where the middle is, but you can't find out specifically what the value is. Okay, there's part D. Again, histograms are not meant for us knowing the specific values. It's just letting us know the frequency of how often numbers are in a specific range. Okay, and that is part D. Okay, for part 4, the enrichment, you can do that. It's more challenging. Here are all of the state populations in 2019. Whoops, I don't know why this is here. Let me just delete this. So typically we would use like a Google Sheets or something like this, just like the project we went on in school. So if you want to check out the answer key for this one, just take a look at the exemplar that is shared for the project. So if you were able to do parts 1 through 3 and that made sense, this is just the same thing with larger numbers. We would just find all the information using these numbers here for the populations. So if you're interested in seeing this part, I recommend that you go check out the completed Google Sheets that has all these answers located there. All right, so hopefully you found this helpful in understanding and seeing if you did your work correct or not. And otherwise, keep up the great work, and I'll see you in the next one. See ya.